All right, hopefully this will be the last one today to also refresh your memory with assembly as you're going through Verilog. Okay, so on the left we have the C code, on the right we have an example of what the text or the assembly code would look like. So sub, they're just talking about subroutine. Return 2 times x, there's x plus y. And so in A, they're going to call A to I on the first argument, and then, oh, they're going to pass argc. Yeah, my code doesn't do that at all. And then A into it. Well, mine's going to do something a little different. What do we call this one? 05. Because we did 04 last class. What's that? And now for something completely different. Okay. So data section, format EAX equals this guy, followed by a new line, followed by terminator, so we know that's the end. There's our sub function. Well, let's see what it does. First, we push EBT like we've been talking about, move ESP into the EBT, so now we have the right stack pointer. EBP, thank you. We're going to get EAX, which is 8 from the top, into 8 from the top of EBP. Okay, it's really important to look at the stack here before we call sub. So it's going to start grabbing some things from the stack, shoving them into registers, and then move it back. Well, before we can figure out what those values are, we're going to need to see how it's set up. So let's go down here and see how we set it up. Well, first thing we're going to do is we're going to move well, we're not even going to do that. Here we go. Well, all right, we'll start with this. Well, we're not even going to call it subroutine. The first thing we're going to do is actually call A to I. All right, this part might be a little confusing, but what is happening is that EAX is going to go 3 back, because if you want to know, if we run this program, and we'll pass it 3. All right, what does this stack look like? I'm drawing it the wrong way. All right, that's enough. Okay. This piece right here, this is going to be the instruction to return. Above that is going to be, hold on a second, what is that one? What is that one? I don't know what this one is. This is the 3. Actually, it's not even that. It's a pointer to the 3. What was the one in between? I forgot. ECX. A, ECX, to I cannot remember. Well, anyways, when we call A to I, notice that we pushed twice, and the reason for that is we were storing a pointer to what was being passed in from the command line. How did this get put there? The operating system put it there for you. So before your program began, the operating system set a lot of things up. Isn't this kind of this is definitely more complicated than the MIP simulator, isn't it?
Yes.
This is way more complicated.
Yeah, that's why I was sitting at this crank.
Yeah. If it was me, we'd still be doing MIPS. Because this just gets complicated. We call it afterwards, we add 8 to push, because we pushed twice, and then we're going to move the result from EAX into EBP, which is going to be the first value. And then we're going to move, the Y argument into EDX. So EDX will be the first one. We push that on the stack. We move X, in this case 1, push that on the stack, and then we call sub. So let me go ahead and show you what sub looks like, because I believe that one's going to make a lot more sense. Okay. So let's do this one line at a time. Whatever's above it is all the stuff that's been necessary up to this point, and we're going to say, let's see, we are right here. Well, what does that do? It copies EAX in there. Well, what's EAX? EAX is 3 at this moment. Why is it 3? Because we just called A to I on the 3 that we passed in. By the way, those of you looking at home, let me go ahead and get the camera up so you can see what I'm talking about, because it's kind of confusing. Here's my big fat hand. So we're calling our program, passing in 3. EAX at this point is 3 because we just called A to I on it, and its return value was set into EAX. Over here, now we're at the piece of code where we're going to move the value of EAX to EBP or ESP. These are actually both pointing to the same thing right now. Right here. Well, if we're going to do -4 and FFF is up here, then that means after the EBP, we're going to put the value 3 inside of memory. Because remember, 0 is down here, FFF's here, so you subtract 4, it's actually down here, you're writing the 3. And then down here, we're actually going to move it into EDX. Kind of a silly way to do it, but that's the way the code generates it. We're going to push EDX. So what that does, again, kind of complicated, but it's going to push 3 back on the stack. Seems a little silly, but that's what it does. And then moves the pointer right here. Then we're going to put EAX to 1. So that's what we set right here. Set up to 1. Up to 1. And then we're going to push EAX. So when we're pushing EAX, we're going to put the 1 right here. Stack pointer is then decremented, so to speak, down to here. Then we're going to call sub. When you call sub, the first thing it does is it pushes the instruction address. I'm just going to make that an @ so it knows that it needs to come back right here. So it's going to put the instruction address of this instruction on the stack when it calls sub. So when sub is called, this is what the stack looks like. AKA when we're right up here, before we do the push, this is what the sub looks like. And this is the instruction of what it's going to return after the function sub. You got that? Oh. Everything good? Excellent. All right. We're going to push the EBP of the return, and then we're going to update the EBP and the EAX to point right back here. Okay. Now, next we're going to move +8 into EAX. That's the 1. There's the 1. Then we're going to move ECX. Now it's going to be the 12. That's why it's adding CH, or C, sorry, and that's in hex. And then it's going to do the calculation of ECX plus EAX times 2 and store that into EAX. So what's that going to be? So what's 2 times 1 plus 3? 5. Then we're going to pop the EBP. And then we're going to call return. And that'll jump us down to here. Now,
what is LEA again?
I can never remember. Load extended address. It's a trick in order to, it's a special instruction where you can do a multiplication and a division at the same time. Why is it called something with addresses? Because a lot of times with an address, you're doing you're doing a calculation for the base, which is a multiplication, and then an offset, which is an addition. So that instruction is very common, so they encoded that entire thing into one instruction. Complicated, but that's how x86 works. But it's a trick that if you're not using it to calculate an address, you can use it to just do a multiplication and an add real fast. So that's what they're doing. And then when we come back, we're going to take the ESP and then have it totally ignore that 3 and that 1. Well, let me jump back here. By the way, I'm on this instruction. ESP was pointing here, now it's going to point right there. Then it's going to call printf, and it's going to do all that again, but by setting it up to printf so it can call the proper values to printf. All right? How are we doing? We'll go and do a make. So we do 3, it's 5. If we do 4, 6, ooh, how about 5? 7, all right. Because we're getting the value from the command line, and it looks like it's just incrementing it for now, which is fine. Okay. That's all I'm going to, I believe that's all I'm going to do. Let me check on Scrum Do. I don't think I'm going to assign anything today.
Aside from what you already assigned.
Oh, wait a minute. Let me look at this one.
No. Please stop. Stop.
No, I'm not doing this one yet because we haven't done multiplication, division, and subtraction. So we'll get to that hopefully next time. But that is all for today. Any other questions, comments, screams? Oh, I'm getting better screams.
Don't forget to do the bin thing.
Upload the code.
Oh yeah, upload the code. Get started on your Verilog. It's going, the big project is I think 20 points or something. It's a lot of points.
It's true.
What's the name of the big project again?
Single cycle processor.
Got it.
Also,
Okay.
you said you were extending the due date of the gate by a week?
Yes. Oh, we didn't do our component presentations.
Aww.
Oh, man,
Oh.
Oh, we need to do this.
Oh, we do need to do that.
I
So
won't
on
call
Tuesday,
kids.
FYI, all y'all who are here, you are to create a presentation from one of the components in the single cycle processor section that we have talked about. You must clear your selection with me, and your presentation will include the following right here. You will present each section because I'm sure every section is very complicated, and I have probably, while I've explained it numerous times, I want y'all to explain it to me so I can make sure that we've all heard it plenty of times, and that way when you complain to me that you have no idea what I'm talking about, at least then I know someone else has tried. That's not a jibe or a dig, that's just, I've just learned that this is difficult. All right, and
We were supposed to
We will-
present it yesterday, apparently.
Yeah.
man, we are really behind.
We did
So
like that.
next week, wait, is the week after next spring break?
No,
It's
the week
the
after next
9th
is
to the
our original
13th.
due date. No, yeah, the
Spring
original
break?
due date for the gate 2.
Hold on.
Spring break is on the 9th to the 13th.
And then the week after that will be spring break.
Okay, good. So you're gonna have a week to do this.
It's not that bad.
So this is gonna be, we're doing this on
I'm gonna call dibs on.
Yeah, so it'll be, well, no, spring break is 9th through 13th. So this will be, your presentation will either be the 3rd or the 5th. It'll be the last thing.
Is that
Do you wanna
cool?
make it the last thing before spring break?
I love it.
Might as well get it out of the way.
Is that a built-in
Last day?
Linux?
Yes,
So
it's
you have
been
to
there
jam
since
with
the
it.
beginning of time.
What? I didn't know that. That's really cool. Sorry.
It's okay.
I called dibs on it.
Well, I mean, you can also change the date, like you wanna know what it would be in 3020?
Whoa.
Whoa!
That's crazy. Are you gonna take a list? Because I want to call dibs
Right, so on Tuesday, we're gonna make the list.
next week.
Yes, so
Okay.
you wanna be here and call
Yeah.
dibs on the easy ones, right, Holland?
No, I'm not calling dibs on these. I want to carry out.
That's a great question. You should go review them and find out.
Man, fine. I'm gonna call. I already know.
People are gonna end up presenting. I call it being the first choice.
A lot.
Yeah.
I don't care. Just give me the easy one.
I called dibs on whatever I did last year.
Good luck with that. All right, I will see y'all next